Okay, this is geometry 5.1. The area of an equilateral triangle of side. There's a lot of formulas. Okay. Since there's a lot, oh, let's come. Uh, I'll be writing them down as I go, and then at the end I'll just show you them all so you can screenshot. For the area of an equilateral triangle of side 6. What's the area? Let's start the first formula. Area of equilateral triangle. Equilateral triangle is s squared radical 3 over 4. Okay, let's apply that here. S squared radical 3 over 4. So it will be 6 squared radical 3 over 4, which is 36. Radical 3 over 4, which is 9 radical 3. It's 36 and 4. Question 2. Uh, area of a trapezoid. Second formula. Area of trapezoid. Uh, it's base 1 plus base 2 over 2 times the height. I think everybody's familiar with this one. Base 1 over here is 30. Base 2 is 58. And the height is obviously 24. This isn't the height. The height is the perpendicular one, huh? Please don't take 25 as your height. Uh, only grade 5s make this mistake. Please take 24 as your height. المهم, it's going to be 58 plus 30 over 2 times 24, and you get 1056. Question 3. Given a regular hexagon whose apothegm is 10 radical 3, find the perimeter. Okay, now hexagon. Hexagon has its own formulas, okay? Before going into hexagon, I'll give you the area of a polygon. Okay, any polygon, okay? Polygon any shape. Any shape, a regular polygon. Regular polygon. The area of it is A times B over 2. A is the apothegm, okay, and P is the perimeter. I'm just gonna write this here for now because we're gonna need it later. Now they're saying given a regular hexagon whose apothegm is 10 radical 3. There's a formula to find the apothegm, okay? The apothegm equals s radical 3 over 2. This is for a hexagon, okay? What do they ask for? They want the perimeter. You know how the hexagon looks, yeah? 1, 2, 3, 4, 5, 6. Well, okay, that's close to a hexagon. Uh, They want the perimeter. Perimeter means you add side, 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 side. They want the perimeter. So we need the side first if we want to, if we can find the perimeter of the hexagon. How do we find the side if we have the apothegm? We said the apothegm is equal to the side radical 3 over 2. What is apothegm? The apothegm is 10 radical 3. 10 radical 3 equals s radical 3 over 2. Let's cancel radical 3 with radical 3. You'll get s over 2 equals 10. So s equals 20. Can we find the perimeter? Now, since we know the side is 20, so we have 20, 20, 20, 20, 20, 20. It's 6 times 20, because it's a hexagon. Hexagon 6 sides. You get 120. Question 4. The area of an equilateral triangle of side length 8. Again, area of an equilateral triangle. We have the formula. It's s squared radical 3 over 4. We do 8 squared radical 3 over 4. 8 squared is 64 radical 3 over 4. Cancel, cancel. You get 16 radical 3. Please don't put it in a calculator because maybe it might give you decimals as an answer. Just put the radical 3 on the side and just do 8 squared over 4. Question 5. Uh, what's the area of the figure? Okay, this is a trapezoid. We need base 1 plus base 2 over 2 times the height. We have base 1 and base 2, 5 and 9. But we don't have the height, but we do have this 6 and we have this angle over here. So I can give you the formula, but I also want you to understand. The formula is going to be base 1 plus base 2 over 2 times Okay, if they have, let's call this side the let's call it L. Okay, it will be L sine alpha. Okay, this is the side. This is the formula if they give you this side and this angle. To understand it, you can see we want this height, yeah, and this forms. This we want this height, yeah. Oh, again, I messed it up again. We want this height, and this forms a triangle. Okay, right triangle, which has 60 degrees over here, and which has 6 over here. We want this side. This is opposite, and this is hypotenuse. Opposite, hypotenuse. That's sine. Sine 60 equals that height, right, over this side that we call L. So how would you find the height? It would be sine 60 times L. Okay, so that's why I say L sine alpha. Uh, and you're gonna get 9 plus 5 over 2 times 6 sine 60, which is 21 radical 3. Question 6. Uh, area of a regular hexagon. They want the area of a hexagon whose apothem is 6. The area of any hexagon or polygon, like we said, is AP over 2. For a hexagon, since hexagon is a polygon, for the area of the hexagon is AP over 2. We have the apothem, which is 6 times P over 2. So we just need the perimeter, yeah? Do we know how to find the perimeter? We said the perimeter is 6 times the side. We solved the question like that. But do we have the side? No, we don't. We have the apothem. How do you find the side? You know, the apothem is S radical 3 over 2. So 6 equals S radical 3 over 2. Multiply 2 on the other side, you're going to get S radical 3 equals 12. And S equals 12 over radical 3. If you put that on a calculator, it's 4 radical 3. So the side is 4 radical 3. Can you find the perimeter? Oh, that ain't a P. P equals 6 times the side, which is 6 times 4 radical 3, which is 24 radical 3. So that's my perimeter, yeah? It's going to be 6 times 24 radical 3 over 2. I'm not sure if the calculator gives you a decimal answer. In case it does, just put the radical 3 on the side and just do 6 times 24 over 2, and then you'll get 72. And just take down the radical 3, 72 radical 3. Okay? Just in case it gives you a decimal, just solve without the radical 3. Question 7. Okay, this question, I'm not gonna say wallah, but I think it's gonna come written. Okay, I really think it's gonna come written. Pay attention with me. I'll give you the steps. Okay, so we can solve. Look, I figured out while solving صراحة that this triangle, I don't know if you guys have a different way. This triangle is similar to this triangle. Okay, that's what I figured out. Why? I genuinely still don't know. Yeah, for this triangle, for this question, okay, they're saying what's the area of BAE? BAE is over here. Okay, I'm gonna give it to you here. This red triangle BAE is similar to this triangle ADM. Okay, obviously not in that order, but these two triangles are similar. I don't think the proof is required if it comes in written. In case it comes written, just say AA postulate. Okay, just say AA postulate. You don't have to prove it, but just say AA postulate. Uh, just say, write it like this. Okay, triangle EBA is similar to triangle. Since E is the right angle, you have to start with the right angle, which is in this case M. And then B, which one's congruent to B? It's A. Okay, just memorize it like this. Okay, it's A. And which one's congruent to A, this A? It's D. I'll show you why A and D are congruent now. If you look here, this is ED, yeah? And this is parallel line, parallel line. Okay, this angle here is congruent to this angle here. If you remember from grade 8, corresponding angles are congruent if it's a parallel line. That's just how you write it. المهم, these two triangles are similar. What does that mean? Okay, this is our next formula. In red, area of triangle 1 over area of triangle 2 equals side 1 over side 2 squared. Okay, what does this mean? Let's see here. EBA, that means the area of EBA, area of triangle EBA over area of triangle MAD equals side 1, or let's look at the sides that we have. The sides that we have, I have this side, right, which is the hypotenuse. So that's part of EBA, 15, over the hypotenuse of this one, which is 5 squared. Okay, 15 over 5 is 3, so 3 squared, so that's 9. The area of triangle EBA, we don't know it, so let's just keep it as area of triangle EBA over the area of MAD. Or I'm just gonna write triangle MAD, I'm not gonna write the area. Okay, we need this triangle MAD, okay? Can we find it? Can you find the area of this triangle over here? 5, 4, is right angle here. Obviously you can. It's base times height over 2. We know the height is 4. We need the base. Obviously 5, 4. The third side will be 3 because you know the Pythagoras theorem. This is a Pythagorean triple that most people are supposed to know, by the way. 3 squared plus 4 squared equals 5 squared. This is the Pythagoras theorem. Okay, you're gonna get this side is 3. المهم, you're gonna figure out that this side is 3 and that you're gonna get the area is 3 times the height 4 over 2, which is 6. Okay, let me just repeat this because I think I said it a bit too quickly. I have this triangle here, 4, 5. I need to find the area of it, and it's a right triangle. To find the area, it's BH over 2, right? Base times height over 2. I need this base. Okay, how do I find it? It's going to be Pythagoras theorem. X squared plus 4 squared equals 5 squared. You're going to get x squared equals 5 squared minus 4 squared, which is x squared equals 9, x equals 3. Okay, for this side is 3. For the base is 3. You're going to get the area is 3 times 4 over 2, which is 6. So the area is 6. So that means we can replace the area of triangle MAD with 6. Area of EBA, we don't know it. Let's keep it as EBA over 6 equals 9. How do you find EBA? Multiply 9 times 6. EBA equals 54. There is another way of solving. Okay, but you still need this first step. The first step is very important. Okay. Actually, not. I'm not gonna give you the other way. The other way is a bit. It's harder. صراحة. Use this way. Just you need to find the area. Not that hard. Let's continue. So we found this is 54. What's the area of ABCD? It's a parallelogram. Let's write down here the area of a parallelogram. Area of I write it like this, equals base times height. So the area of ABCD, the parallelogram, is the base 15. If it's 15 here, it's 15 here, obviously, times the height, which is 4. So 15 times 4, 60. Then what's the area of the whole polygon EDCB? Obviously, you just add up the triangle and the parallelogram. 60 plus 54, 114. Question 8. Again, area of equilateral triangle. It's s squared radical 3 over 4 for 144. Oh, whoa. It's gonna be 12 squared radical 3 over 4, which is 144 radical 3 over 4. Cancel, cancel. You get 36 radical 3. Question 9. Same thing. When you have the angle and you have the side L, okay, the area equals base 1 plus base 2 over 2 times L sine alpha. Use this formula I gave you. I'll write it down here. Trapezoid, or base 1 plus base 2 over 2 times L sine alpha. If they give you, oh no, these should be congruent, I think. Wait. I doubt they do it. I really doubt they do it. But if they give you this angle, then you just do 180 minus this angle, I think. Wait. Yeah, I googled it. If they give you this angle, you just do 180 minus this angle. In case they did, they probably won't. But yeah, I don't know. Maybe. Yeah. This regional likes to bring stuff. So base 1, base 2 will be 16 over 2 times 8 sine 60, which is 8 times 8 sine 60, which is 32 radical 3. Question 10. Area of a regular hexagon whose aperture is 12. Again, to find the area, it's A times P over 2. So we need the perimeter, and you know the perimeter is 6 times the side for a hexagon. How do we find the side? We know we have the apothem. The apothem is equal to S radical 3 over 2. To find the side, apothem is 12. 12 equals S radical 3 over 2 multiplied by 2. 24 equals S radical 3. S equals 24 over radical 3. If you put that on a calculator, it's 8 radical 3. Okay, for the side is 8 radical 3. The perimeter will be 6 times the side. For 6 times 8 radical 3, which is 48 radical 3. Now we can solve A times B, so A, which is 12, times 48 radical 3 over 2. I think my calculator gives it to me as a decimal. Yeah, it gives it to me as a decimal. Just solve without the radical 3. So just put it as 12 times 48 divided by 2. And you get 288. And then take that radical 3, put it here. It'll be 288 radical 3. In case your calculator gives it to you in decimals, that's what you should do. Question 11. Same style of question. I'll go over it a bit quicker this time. Okay. Area of LKP. Write down on your written, LKP is similar to, let's see, this angle is always with this angle. For L with K. So K, and then angle K over here, we said is equal to N, right? N, because the parallel lines corresponding. Okay, so N, and then P obviously is equal, the right angle is equal to the right angle here, H. Okay, that means the area, okay, say AA postulate, huh? AA postulate. They might deduct marks for it, I don't know. That means the area of LKP, if I'll just write triangle LKP, I won't write area, over triangle KNH equals S1 over S2 squared. Okay, let's pick out any two sides. We don't really have a choice. We only have 20 for this LKP, but it will be triangle LKP over triangle KNH. The side one, we're going to use 20. Since this is the hypotenuse, you also have to take the corresponding side. So also have to take the hypotenuse here, which is 10 squared. You're going to get triangle LKP over triangle KNH equals 100. ايش 100? 4. It's going to equal 4. Because 20 divided by 10 is 2, which 2 squared is 4. Okay. KNH. Can we find the area of KNH? Yes, we can. If this is 10, this is 8, this will be 10 squared minus 8 squared equals that side squared. Because remember, I'll write it differently because some people get confused. Call this side x. Use Pythagoras theorem, x squared plus 8 squared equals 10 squared. X squared equals 10 squared minus 8 squared, which is 36. X squared equals 36 for x equals 6. Okay, because 10 squared minus 8 squared is 36. X equals 6. You get this side as 6. Okay, can you find the area of it? Base times height over 2. For 6 times 8 over 2, and you're going to get 24 as that area. For triangle LKP over 24 equals 4, cross multiply 4 times 24, you get 96 as triangle LKP. For part B, whoa, I must. المهم, part B, what's the area of KLMN? It's a parallelogram, and we said it's base times height. The base is 20, same up and down. 20 times the height, which is 8. So 20 times 8, 160. And then I think for part C, they ask for the total area. PLMN, yes, you just add them up. 96 and 160, you get 256. Question 2. Was Oh, ya Allah. Okay, we back. The Wi-Fi is back. If the perimeter of a regular polygon is 20 and the apothem is 4, what's the area of the polygon? Okay, this is very easy. Like I said, the area of any polygon is AP over 2. It's 4 times 20 divided by 2. 40. That's it. No yap needed at all. Just 4 times 20 divided by 2. Question 13. What's the area of triangle ABC? Again, very simple. You just use the basic formula of the triangle. The area of a triangle is BH over 2. So 10 times 6 over 2, which is 30. Question 14. Area of the trapezoid. Again, these are the basic applications of area. Base 1 plus base 2 over 2 times the height 6. So 12 plus 4. I'll write it in case. 12 plus 4 over 2 times 6. 16 over 2 times 6. So 8 times 6. 48. Question 15. Inshallah, they're all easy. The area of the parallelogram, again, just do base times height, 20 times 12, you get 240. Question 16. The area of an equilateral triangle with side length 60, again, you have to use the formula s squared radical 3 over 4. So 60 squared radical 3 over 4. I think your calculator will give you a decimal, but just keep the radical 3 on the side. So be 60 squared divided by 4, you get 900. And then you put, actually no, you don't need the radical 3. They want only k. So you just put 900. Question 17. The length of the diagonal, okay, we need this one. The area of a rhombus is actually area of the rhombus is equal to d1 d2 over 2. This is diagonal 1, diagonal 2. Okay, so diagonal 1 times diagonal 2 over 2. For 12 times 8 divided by 2, which is 48. That's it for 5.1. Thank you so much for watching. Good luck.